Hi everyone, welcome back to Java 1 for All. Before we get down to business, let's understand a little bit more about the collections and something that we called time complexity. So basically, when we talk about collections in Java, they can be either sorted or ordered. What does it mean? When we talk about ordered collection, means that the elements of the collection, they have a specific order. For example, they can be order of insertion if we are talking about arrays. And the order is completely independent of the value. So if you have an array, you just keep adding values to that array, and they are ordered basically by the array index. And sorted collections means that not only the collection have an order, but the order also depends on the value of the element. For example, let's say that we have a collection, a sorted set, that every time we add something there, we are sorting based on the name. So if you are having a collection of names, every time we add one name, the collection should be sorted and reordered to have the whatever we define, if we want like from A to Z or from Z to A. Now, based on this, we have all the collections, not all, but this is just a very tiny piece of the collections in Java. You have several thousands of pictures exactly the same. So big thanks to TechVidvam, and I'm just going to reuse your picture. Now, take a look at this picture. Based on this, you can tell that the collection framework, it's pretty high cohesive. Each one of these classes and interfaces, they have a specific purpose. That's why you can see that we have implements and extends everywhere. And when I talk about collection, sometimes I'm talking about most of the times I'm talking about the collection of data, but we have to be careful because we have a collection interface. And the collection interface is what defines if this is a collection, if this passes the test is a collection. So look at this picture. When I talk about list, queue, and set, I'm talking about the interfaces that are collection because they are they are implementing, actually extending because they are interfaces as well, collection. But the map, that's also a collection of data of key value pairs. They are not collection itself. So just for you to be aware. And as you can see here, the collections usually we are programming oriented to interfaces. And the reason is because we can change the behavior by changing the object. So for example, I have a list as reference variable, and then I have array list as object. Let's say I would like to change the performance because, as we are going to see at the time complexity, sometimes things change when you have different type of data structures. And technically, we just have to change the object, and the code should work flawlessly. Now, this is just a quick overview. Of course, we are going to talk about most of them and even more. But what I need you to understand that when we are working with collections, that is something related that is called time complexity. So I'm not going into details about time complexity because, well, it can get pretty boring if you are not into data structures and algorithm. But what you have to understand is that time complexity, it will define the operation and the elements. So basically, the more you have you grow your collection of data and you are doing operations, this is going to tell you how long it's going to take. So for example, if you have like 10 and you have what they call quadratic value, O, this means that the more it grows, the more time it will take for your operation to complete. And if you are working with collections, what you should look for is these two values. Basically, this one is the best. It means that it's like a constant. It will not change and it will always be the same. And when you are looking, this is just a data structure, not Java related itself, but always look for the worst case. So for example, if you are trying to search for a collection that's very good for access, if you take a look here, array is your choice. But for example, if you're looking for a good collection for insertion, array may not be the best. So for example, can you use queue in this case, because queue has a better performance for insertion. So it all depends what you actually need. And we also have, for example, this list. It's again everywhere in the internet. If you search for Java collections time complexity, this shows you some of the collections and maps that we have and the time complexity of their operations. So for example, we have here array list and linked list. Basically, linked list will have a reference to the element in front and the element at the back. Array list, you always have the index, and this has a difference in the time complexity of the operations. So for example, if you are going to create a collection where you are going to get a lot, it's better for you to use array list. But for example, if you are going to remove a lot, you better maybe go with linked list. So it depends on the operation that you are going to use more. So for now, we don't have to worry about it because it can get pretty heavy. But later on, when you are working and you are in your job and you are trying to decide which collection you're going to use, think about what kind of operations you will be doing. Sometimes you are searching more, sometimes searching for contains, or sometimes you're just removing, sometimes you're just getting. You have to think about what you're trying to achieve and the time complexity that we have available. So this will avoid you having performance problems in case of scalability. So with all of this in mind, I think it's time for us to start writing some collections. So let's go to the next video. Bye.